Hello Algebra 1 students. Today I'd like to take a look at page 19. I'd like to maybe break down each particular question if I could, or at least most of the questions, and see what the math entails and what the logic entails. Identify the sample and the population for each situation. Then describe the sample statistic and the population parameter. Number 1. Restaurants. A restaurant randomly selects 10 patrons on Saturday night. The median amount spent on beverages is then calculated for the sample. So we're going to start with the sample. And if this is obvious in this particular instance, the 10 selected patrons are our sample. Which then speaks to the population next. Usually the population follows the sample, population being larger than the sample. And that particular population speaks to all patrons on Saturday. And then we talk about the sample statistic and the population parameter. The sample statistic stems from the sample, of course. And in this case, because we are provided what? The median amount spent on beverages, that's exactly what we're going to go ahead and note. It's very specific, and it's specific to the sample only. Median amount spent on beverages. While the population parameter we're going to go ahead and break that down as similar to the sample stat, but a little bit larger, of course, the median amount spent on beverages on Saturday night. So it's really the same type of thing we're thinking about or looking at, except it's a larger kind of perspective. The median amount spent on Saturday night. So that speaks to problem number 1. Let's take a look at another one. I'm going to actually jump to problem number 3 and do the produce problem. And we'll take a look at some other questions, of course, after that, doing some math. Produce. A produce clerk randomly selects 20 bags of apples from each week's shipment and counts the total number of apples in each bag. The mode number of apples is calculated for the sample. So let's start again with the sample. So for our purposes here, we're looking at what? The 20 selected bags. I'll be even more specific. We're talking about apples. So 20 selected apple bags. Okay. And then we move on to the population. Population, of course, larger than the sample. In this instance, we're talking about obviously a bigger picture here, so all bags of apples in the week's shipment. And now we can go ahead and take a look at the sample stat, which stems from the sample. In this case, we're looking at the mode number of apples. While the population parameter is the mode number of apples in the week's shipment. So you see the connection between the sample and the sample statistic, but also the population parameter. Very much tied together. Let's move on. Seeing what the mean absolute deviation entails on some of these. I think it would be wise for us to maybe take a look at at least one of 4 through 6. Then we'll talk about 7 through 12 and then even 13. Number 6. Xavier keeps track of how much money he spends on gasoline each week. So we have 1, 2, 3, 4, 5, 6, 7 data values. And we'll go ahead and take a look. For our first particular analysis, we'll try to reflect upon what a mean absolute value deviation is in the first place. So if we recall, and I'm going to scroll back here. So mean absolute deviation, if you remember the example from our notes, the mean absolute deviation is a three-step process. We first find the mean. We then find the sum of the absolute values of the differences between each value in the set of data and the mean. And then lastly, we divide the sum by the number of values in the set of data. So let's start with the mean. So to find the mean, we obviously take our numbers and we add them up. 20, 13, 26, 0, 33, 16, and 18. We'll go ahead and do that. I'll use my handheld graphing calculator here. If I add all of these numbers, we are going to end up with a sum, again, 20, 13, 26, 0, 33, 16, 18. So that adds up to 126. How many numbers are there? Well, 1, 2, 3, 4, 5, 6, 7, we said, giving us a mean of 18, or average. Now remember, that's not just it. Okay, once we find our mean, and we take each value, really all 7 of these, minus 18, we want to do the absolute value. Not only are we doing that, as we reflect back again momentarily here, we're actually finding the sum of those respective sums. Okay, actually the differences added together, and then we'll see what we end up with. We should end up with a positive number because the absolute value always ends up in a positive. So differences of the data values and the mean, absolute value added. So let's do that. So we're going to first start with 20 minus 18, which is 2. And I'm doing the absolute value, but in this case it's already positive. 13 minus 18, which is negative 5. I'm going to take the absolute value and just make it 5. 26 minus 18, which is 8, already positive. Keep going. 0 minus 18, absolute value, we do have to make that positive, so 18. 33 minus 18, 15. We keep going. 16 minus 18, of course, is negative 2, absolute value of which is 2. And then lastly, 18 minus 18, so 0. So if we add these numbers, 2 plus 5 plus 8 plus 18 plus 15 plus 2, we don't really need to add 0. We end up with 50. Okay, so that speaks to step 2. Now we look at step 3. Step 3, if you recall, we'll look at it again momentarily. It says divide the sum by the number of values in the set of data. So we did say we had 7 values, so let's take that number and divide it simply by 7. And that then leads to our answer of 7.14. So that is the mean absolute deviation. As we graduate towards the mean variance and standard deviation for each set of data, really all of these problems are fairly good to interpret and take a look at. We're going to go ahead and pick one of them, 7 through 13. And if I go ahead and maybe take a look at the question here, number 11, and go ahead and see what this is going to entail. Remembering that the mean, again, is just the sum of the numbers, so 23 plus 18 plus 28 plus 26 plus 15, add up, and you end up with 110. We have 1, 2, 3, 4, 5 numbers, so that lends itself to a mean of 22. Okay, so that's easy enough. That speaks to, again, the average. Mean is the average. And then what about the variance? Okay, so the variance, as we reflect back again, the variance is the square of the difference between the two numbers, the data value and the mean again, added together and again divided by whatever the number of numbers is. So we're looking at sigma. The symbol here is sigma, sigma squared. So let's do that math. It's kind of like actually the last type of situation we went through with the mean absolute deviation, except in this case we're not doing the absolute value. Actually, we're taking the difference and squaring them. So let's do that. So we simply take, and I'll do this on my calculator here, 23 minus 22 quantity squared plus, in parentheses, 18 minus 22 quantity squared plus, parentheses, 28 minus 22 quantity squared plus, parentheses, 26 minus 22 quantity squared plus, and then lastly 15 in parentheses minus 22 quantity squared. Now, taking the difference and then squaring them will result in a nice positive number, of which I'm getting 118, and we'll divide that by 5. And again, this is sigma squared. If you do the math, 118 divided by 5 is 23.6. Alright, that's all fine and good, but we still have to finish off this problem. And if we do so correctly, it's really just a matter of taking the square root of both sides. The square root of 23.6 then lends itself to 4.86. Alright, so this concludes our discussion on the homework problems today. Now, I didn't go over every single problem, but I did do every single type of problem. I hope that this makes sense. We will discuss this more in depth tomorrow.